Good morning, good evening, good afternoon to everybody out there today from the Element 14 community. I'm Phil from the Element 14 community. Today we're joined by Roger Thornton, Raspberry Pi Director of Applications. How are you doing, Roger? You okay?
I'm very well. How are you, Phil?
I'm good. Today, this is a live webinar. You will be able to watch it and send it to your friends and colleagues as the VOD will be available pretty much immediately after this webinar is finished. We're going to be talking about the Raspberry Pi 2040, which is fantastic. A lovely piece of Raspberry Pi silicon, which has been very exciting. We do have a quiz down at the bottom. If you enter it, you will get a certificate emailed to you for your attendance. The questions, the Q&A box is live. You can ask us questions throughout. I'll be jumping in, and at the end, we'll have some Q&A time. On the right-hand side, we also do have some resources. If you want to learn more about the Raspberry Pi, check out any of our 10 years of Raspberry Pi celebrations on the Element 14 community, or even get hold of the giant Raspberry Pi 3 that we are giving away. All you need to do is tell us where you want to display it, and it could be yours. Check out those URLs on the right and hit us with some questions. But I'm just going to hand it straight over to Roger. Roger, please take it away. Thank you for joining us.
Thanks, Phil. Thank you, everyone, for tuning in to sort of hear me talk about RP2040. So, really what I'm going to do today in the next sort of 20-25 minutes is give you all an introduction to Raspberry Pi's first in-house designed microcontroller, give a bit of history about where it came from, talk about some of the technical details of it, look at some of its uses at the moment, and how to design with it as well. As I said, I'm Roger Thornton. I'm Director of Applications at Raspberry Pi. The applications team really focuses on helping customers take Raspberry Pi technologies and embed them into their own products. So I deal primarily with business, sort of the commercial industrial side of the world, helping customers take a technology like compute module or RP2040 and embed it into their products and get the best out of it, and sort of take any learnings we have and try and feed that back into product design in the future. So, for those familiar with the Raspberry Pi product line, you'll all sort of recognize some of the things on the screen at the moment. Raspberry Pi is famous in its bread and butter is single board computers. But, coming up now to our 50 millionth Raspberry Pi sold, which is a grand achievement, and that's where Raspberry Pi has been in business for the last 10 years, designing and selling computers. The compute module concept came along a few years ago, and that really what that is sort of a deep embedded version of Raspberry Pi. It removes all the connectors and makes it an embeddable product. And recently, in the fourth generation of products, we've added an all-in-one style computer. So that's a kind of the harken back to the Amiga days, where it's a computer inside a keyboard. And there's a growing line of accessories. And what's noticeably missing from that is sort of an Arduino style, a microcontroller board. We've been going for 10 years and never released one. And the real question for us was, what microcontroller do you use on this kind of board? And about 6 years ago now, we set out with the conclusion that we couldn't find the right microcontroller. So we set out on the mission to design our own. And that's what we are talking about today, which is RP2040. This is Raspberry Pi's first microcontroller that was designed in-house. So this means the silicon design of the chip was done by Raspberry Pi engineers. So we like to say it's designed by engineers for engineers. So it's the idea that we've taken all the kind of Raspberry Pi approach to things and embedded them into a microcontroller. So it's on a modern process node, on a 40 nanometer node. It's got two ARM Cortex-M0 Plus processors in it. It's an on-chip memory and it has flexible interfacing. So we're going to go through all these kind of key points in a while. But what you really want to think about, is a microcontroller it's the bottom left corner of a price performance space. It's a much higher volume product. So as we said, Raspberry Pi has sold 50 million computers now. Every year, there's about 27 to 28 billion microcontrollers sold. So it's just an order, a magnitude of difference in terms of microcontrollers versus computer. So they are far less powerful, but they are cycle accurate, they're deterministic. They're sort of a way of digitally interacting with the physical world. And what we believe we've done with RP2040, which is our first microcontroller, is it takes our signature values of high performance, low cost, and ease of use, and it brings that Raspberry Pi approach to things into the microcontroller space. And on this slide, you can see RP2040 in the highlighted box. There's our synonymous logo, laser etched onto the chips, and all the big players have already made sort of development boards around RP2040, and these were all available on launch, and so it's already been picked up a lot, and you may have interacted with it a lot. So what we're going to do is sort of get a bit more into why RP2040 is. I think to understand RP2040, every company that starts producing chips ends up needing a long part number that's indecipherable. So I thought I'd try and help you understand how RP2040 is named. So RP for Raspberry Pi, of course. First number is the number of cores. So this RP2040 has 2 cores, and then the next type is the type of core. So we have M0 plus cores from ARM, so we have 0 for that. And then the 4 is the RAM size, so the internal RAM. And then 0 is the final number is our non-volatile memory. So it has no on-chip storage at all. And so that gives you an idea of where we can, how we can change things in the future and go from there. So that's a breakdown of what we are there. This is a sort of fantastic image of an X-ray of the die of RP2040. It just gives you an idea of what goes inside a microcontroller. You can see, we have a large on-chip memory, so there's 2 big banks of SRAM. The important thing is they're symmetric, so symmetric dual-core processors, 2 processors, and we have a bus fabric that connects them all, and then a set of programmable I/O that you can play with. I think the important, what we should think about is it's a stateless device, so it needs an external piece of memory on it. But we believe that this gives us sort of the most sort of flexibility in designing products. So it allows you to choose the size of memory and everything like that. So I think the first thing we should really go into detail with is the core and sort of why it's important. We elected to have not 1 core, but a dual core system, but rather than tie each one to a set of peripherals, through the bus fabric, you're able to connect it to the 6 banks of SRAM. So you can, in essence, run DMA engine, so direct memory access on both cores in parallel without any contention. So both cores can function out of separate SRAMs without any contention. On RP2040, we have 264 kilobytes of on-chip SRAM in 6 independent banks. We have DMA controller, and we have this AHB crossbar that allows you to connect any processor or any part of the chip to another. One of the things we've always noticed is that sort of you as a designer are never going to, as a chip designer, you're never going to get the right set of interfaces for every customer. So we believe we've got a reasonable attempt at it. That there's a large number of interfaces. There's DACs, there's ADCs, there's an SPI, there's a QSPI, there's a UART, and there's R squared screen. But this also means at some point you're going to have an interface that you either look to a legacy device for, so say you're connecting to an old piece of equipment, or you are used to buying a microcontroller that has a very specific interface on it, and sort of your design is went to that. And that's where PIO comes into. And PIO stands for Programmable I. So essentially, inside every RP2040, there are 2 identical PIO blocks. And inside each of these PIO blocks is a user programmable state machine that allows you to build any interface you can think of. PIOs are sort of a high throughput thing, so you can sustain 360 megabits per second during active scans, running from a 48 megahertz clock, and so you can build interfaces that you're not used to seeing on a microcontroller. So you can run some displays off it, and you can also run some sort of old style parallel buses and things. And what we're seeing a lot of people picking up RP2040 is taking it and using PIO to interface to some old piece of machinery that the chips are on hideous lead time, or are very expensive, or are becoming end of life. And you can sort of hark back to that idea that we were talking about before, which is microcontrollers are the thing that connects the physical world to the digital. And PIO is one of those kind of unique parts that allow you to create an interface to that world. As we mentioned before, RP2040 is a stateless device. You can connect over QSPI a external piece of flash memory, and you can go up to 16 megabytes of off-chip flash. That'll allow you to connect, store your microcontroller software in there. At the moment, RP2040 comes in a 7x7 56-pin QFN with a large ground slug pad in the center. It's run off it's designed out of a 40 nanometer process. So that means that the silicon inside is just 2 square millimeters, which is incredibly useful at this time. At the moment, being efficient with wafers is become an increasingly useful thing in this time of dear shortage. And that is a unique point at the moment, is due to the way we are, due to our die efficiency and the way that we run our business. Raspberry Pi actually has a good stock of RP2040. So we have one of the few companies in the world that has a stock of microcontrollers. So that is a useful thing. We're seeing a lot of people migrating designs from other suppliers to RP2040, because it's a powerful, useful replacement that is in stock.
Just
one thing to note here.
Oh, sorry. Just one quick question. You might get onto it. Obviously, other than it being in stock and available, why would people move to the RP2040 as opposed to some of the other classic microcontroller packages?
Yeah, I mean, we think our combination of fast clocked dual M0 plus cores is quite compelling. Both those cores run at 133 megahertz as standard. In fact, only a few days ago, our excellent intern, who's sadly leaving us, has spent a bit of time in the lab, and he's managed to overclock RP2040 to run at standard clock speeds 133 megahertz, and it's running at 1 gigahertz. So it's quite impressively overclockable as well. You do need quite hefty cooling equipment and fairly big power supplies, but it is possible. Yeah. And we're seeing people move over because they're dismayed with the sort of commitments that they've had from other vendors. They've found that the speed that the cores are run at is very impressive. And there's another part, which is price. I'll get onto it, but it starts at around 70 cents for this. So comparatively, it is massively cheaper than other parts.
Thank you.
And talking of why you would pick Raspberry Pi, that's a good one. Why would you pick Raspberry Pi over other things? We do some machine learning. So there is a TensorFlow Lite flow. There's a micro library for Pico, which is a Raspberry Pi RP2040 based product. So it allows you to run some machine learning models. So you can do things like voice recognition. You can detect people in images, and you can recognize gestures, all run from RP2040. So there is some light machine learning options available on RP2040. This is a very big and complex table comparing RP2040 to a bunch of like products. But I think the important thing to look at here in this one is really the second to last line, which is whether or not the microcontroller runs Doom. Now, we've tried to get it on other ones, but we haven't been able to. And in fact, one of our excellent software engineers was able to get Doom to run on RP2040. So I've got a little video of it. There are a few shooting noises in it, so be warned.
There we go. If anybody needs to turn it down, there's a volume button on the right of the media player.
But it might bring back some memories of Doom. So hopefully it gives you an idea of the sort of power of RP2040 and a new benchmark set down for microcontrollers. We were talking to one of our big suppliers recently, and their VP of marketing was he said, "Oh, well, you can play Doom on RP2040." He said, "No, surely you can't play it on a microcontroller." And he said, "Oh, look, here you go. What's this fantastic video?" So yeah, it just gives you an idea of how capable and sort of versatile RP2040 is. I'd like to move on a bit about sort of designing with RP2040. A lot of people here will be very familiar with sort of design processes. So, as we said, it's a product designed by engineers for engineers. So we've tried to be as open with all the files as we can. So there are all the CAD is available freely in KiCad. So we give away some reference designs so you can get started. So this picture here is an example of a sort of a kind of minimum design board. So this is everything. This is the least amount of things you need to get RP2040 to boot and run. But you can take that and sort of freely sort of adapt it into your design. We have a place called the Product Information Portal. So that contains things like white papers, data sheets, and information on sort of designing with RP2040. So that's all available there to get through. Our data sheet, data sheets are often overlooked, and one of the things we wanted to make sure of in this was that the data sheet for the chip we launch is something we would not get upset with if we were handed. So it's very easy for us to say our data sheet is good, but I genuinely believe that if you pick it up and have a read of it, you will say, "Oh, that's a good data sheet. It's written properly, has all the information in it I need," and we've got lots of acclaim for that. And so it's worth noting that the reference guides and the data sheet are very good for this. And we also sell physical books. So, sorry, say again?
I was just backing up that the data sheets, the documentation is fantastic. It's one thing Raspberry Pi do very well that not everybody does. The documentation is fantastic.
Thank you. There you go. Corroboration in my wild claim. And so yeah, there's a variety of physical books as well. So we have a publishing arm, and they publish in books. So there are books on using RP2040 to do certain things. And then the final step really is programming. So there's a nice way of programming it over USB. So you can have the device, have RP20 turn up as a mash storage device in a host system, and then you can, as this little image is little GIF showing, you can just drag and drop UF2 files, and it will download the code over USB and store it into your attached flash. Equally, we provide a very polished port of MicroPython for RP2040, so that's really designed towards the sort of hobbyists and sort of beginners, should we say. And then for professional developers, we provide a a C SDK and a GCC-based toolchain, and you can also integrate into Visual Studio Code. There is work ongoing to add other toolchains and things. That's one of the things we've had a lot of feedback on is, well, it doesn't work with the toolchain I'm used to working, or a lot of companies have said, well, this is our environment and we can't really change it just for one part. So we're working hard to try and bring in other toolchains that you can use with RP2040. Yeah, so I guess we've had a look at the technical side of it. We've had a look at the design side and the programming side of it. I think it would be worth looking at some real-world examples of it. And I've picked a few that Raspberry Pi users will probably be aware of, but it's worth going through. Raspberry Pi Pico. This is the product we launched RP2040 with. So we design and sell a very sort of minimal breakout development board / embeddable microcontroller product. So you could learn, you could understand what RP2040 does with this, but equally you can take, if you don't want to design you don't want to do the layout of the power supply and the memory, you can, thanks to its castellated edges, you can actually just solder, you can pick and place a Pico into a product. So Pico's a $4 microcontroller board we sell that sort of shows off all of RP2040's best features. Again, it sort of, you can run it over USB, or you can connect over UART debug. And then very recently, earlier this year, about 2 months ago, we launched Raspberry Pi Pico W. Oh, I dropped a W on this slide. And Pico W adds wireless interfacing, wireless networking to the Pico platform. So this is the same RP2040 based product, but now has BGN Wi-Fi on board, and so it's a fully certified radio module. So you can embed it and sort of skip nearly all the radio compliance work in it. So much like you buy a radio module from any other vendor, Pico W is that, and it's still in that sort of pick and placeable format. So you could use Pico W in a mass production environment, as well as you could use it for small scale developments yourself. And then I thought I'd highlight someone else who's taken RP2040 and built things out of it. So this is our good friends Rack Wireless, and they have a RP2040 based LoRaWAN module. So this is a fully certified LoRaWAN module with RP2040 embedded inside, providing the sort of the compute side of things. It's just an example of where RP2040 is being used. We're also seeing it, it's been picked up widely. I think we've sold around 2 million pieces now. And they're going into all sorts of things. They're in key entry systems. They're being used in input devices. Because of its native USB support, it makes a really good keyboard controller. In fact, you see lots of keyboards being run off RP2040 now. So it's sort of permeating slowly into the world of things that microcontrollers do. It would be remiss if I didn't talk about pricing. So RP2040 in volume sells for 70 cents. You can buy them in ones and twos for $1. 70 to hit the 70 cents price point, it's a reel of 3,000 units. And so we're trying to keep that Raspberry Pi model, which is the sort of the ones and twos price is very close to the highest volume price. So in volume, it is incredibly competitive in terms of price. It is very, very available at the moment. You can place an order on our Raspberry Pi Direct site, or you could use Farnell. I've heard it quite good. And it'll be shipped out in a matter of weeks. So we're sort of very, very pleased to be in this kind of positive situation for distribution at the moment. RP2040 is just the start. There will be more things. You don't build a chip team of quite a lot of people and invest a lot of time and money into to just make one chip. So there will be other things, and I'd love to hear where microcontrollers need to go in the future from your viewers, and how we can make the best microcontrollers. We're a team of engineers that build things that we think we would want, and it's always good to hear what other people need. So you can find out a lot more about RP2040 at raspberry.com. Any questions you have, please email them. We can we'll have some question time now, of course. But if you have a sensitive question or a question that requires you don't want to have broadcast, I'm very happy to answer things. And it's applications@raspberry.com, and that comes to my team, and we can sort of work out how best to help you. So I say thank you for listening to me and a bit about RP2040, and I'm very, very happy to take questions.
Thank you. Well, we got about 25 questions at the moment. For anybody with any more technical questions, I think we've got a second webinar coming up on the 29th of September. I believe that's with James, right?
Yes, that's James Hughes. He's a software engineer in my team. He'll be on there. So what I'm going to do is throw James under the bus and say software questions.
Software questions for James.
You can field them on the 29th.
Got it. Yep. So keep an eye on your emails and the event. We will be publishing the sign up button for that event very, very shortly. We just need to get one or two things signed off first. Right. I am going to go through some of these questions. I'm sure most of them are just trying to get early release up information out of you. So just throw, you can put all 200-300 of us on NDAs, right, Roger? Yeah. Easy, just sign us up.
Yeah,
absolutely.
Super secret new product that we're launching.
Fantastic. Somebody clip it, put it on YouTube. Job done. Okay, so we'll just start at the bottom actually. So Henry has asked, I've got a project using the Raspberry Pi Pico, and it's going to be attached to the body 24 hours a day. Is it safe radiation-wise? That's an interesting question. I don't know if Gary's the right person for that. I don't know if I'd strap something Wi-Fi 100% to my body. I guess I do with a smartwatch.
With anything that emits radiation, any product has a set of emissions on it. Part of compliance work says you have to go measure that and make sure it's not above certain limits. When you get within 20 centimeters of a person, so things like smartwatches, telephones, things like that, they have to go through a thing called SAR testing, which is specific absorption rate testing. And what that does is they have forgive this. So they have, imagine this globe is it's a sort of dummy head. They have a robot that brings the device and places it all around that thing, and inside there's an antenna, and it measures that received the received emissions, and there are very, very strict limits on that. So if you're going to strap it to someone and sell it commercially, it has to go through SAR testing, basically. So your laptops go through it, things like anything that you put on your person goes through SAR testing. I'd happily put you in touch with someone who does SAR testing. Be prepared, it's not very cheap. Involves some clever robots and quite a lot of time. But you need. I can't comment on it because I don't know what the rest of your system is.
Fantastic. Thank you very much. Okay, so Gary asks, does the RP2040 perform better with MicroPython or the Arduino IDE?
I'd say ours is going to be better just because we sort of know the insides and outs of it. So our MicroPython port's probably the best one. But again, it might be a user experience thing that might be different. So I can't comment on that. So.
Makes sense. Gabrielle says, when using PIO SPI, is the way to send more than 32 consecutive bits without delay? That might be a question for James, that one, but I'll field it to you.
There should be. You should be able to get some. If you're looking for a longer data stream than 32 bits, basically, there should be. I think that is an application that Raspberry Pi one, and we will get in touch with the designer of the block and ask him.
Well, feel free to come back with that question on the 29th of September, Gabriel. Yes. And obviously, you are able to post that on the Element 14 community. Just click the Raspberry Pi space link on the right-hand side, and you can ask those questions. Our support community is there for that exact reason. Okay, so Maximilian says, how many years did it take to design the RP2040? How many years has it been in the work? Your own silicon?
It started about a year and year two after I started, so it's six years, I'd say. 6 years since sort of fun drawing on a whiteboard to silicon on the shelf. You know, design probably took 3 or 4 years. There is you know, getting a chip made takes a fairly long amount of time. You know, even on a dedicated wafer, it's 4 to 6 months wait. So it's
Wow.
it's a slow process. Yeah.
4 to 6 months, and then you spot something, and then you have to do another 4 to 6 months. Yeah.
Yeah.
Oof.
That's why it takes a long time, because you kind of don't want to get it wrong first.
I feel this one might be a no comment, but what's next for RP2040 after the Wi-Fi RP Pico?
Well, I think Pico as a form factor has really captured people's imagination. So I think there's likely to be other things in the Pico form factor, and then there will be other devices in the future, I'm sure, that come. And part of doing this kind of discussion is getting feedback on what RP2040 misses. Is there a thing on there that you'd like to see, or better performance, or something like that? So getting feedback from you is kind of the thing that helps us understand what is next as well. So, what Pico version do you want?
We have had a lot of people, I'll condense a bunch of these questions that just outright mention integrated flash, integrated memory for reasonings such as space saving as well, so stacked with integrated memory. So feel free to comment on that, or not, I can just move on.
Yeah, it's a really good idea, and definitely something we've heard as well. So yeah, I think it's a really excellent way forward. Yeah.
Fantastic. Is there? So this is from Maximilian. Do you have a breakdown of which programming languages can be used with the RP2040?
Yes, I think there's some good descriptions in our data sheet. So say we in our toolchain we give a sort of a C SDK and MicroPython work well. I think there are ports of other things there as well. So really depend on what you're looking for more than an exhaustive list is probably the best thing. So.
Makes sense. There's another one asking for flash, another one asking what's next in the way of memory. Okay. The pins capable of handling 5-volt input, or is it 3.3 only?
It's 3v3 higher. Yeah.
Got it. Again, non-volatile memory. Sorry. Yep. That's a good one. So this is a thing that we get a lot of questions when people are on the Element 14 community asking about building stuff into products. What's the expected availability time span for the RP2040? How long can people get this and build it into a project?
So RP2040 is very similar to all our other products. So Raspberry Pi understands how important it is that something you designed in isn't gone the next year. No one wants to be in that situation where they're having to redesign products, like 5-year-old products, because someone's decided to get rid of it. So to that end, like we've never got rid of a Raspberry Pi variant. So you can still buy a Raspberry Pi 1 today, 10 years on, and our software still runs on it. So like there's that embedded kind of idea when we came to RP2040. So we've actually we are, our intention is to keep it going as long as possible. We currently set our sort of expected lifetime to in fact it's 2041 at the moment. So
it's 1 year more than 2040. It could have been a nice round number.
Saying that out loud, I think we might have to redo it just to 2040, just for the nice pattern. So.
Okay, so do you have any middleware libraries to support capacitive touch or capacitive touch screens?
I don't believe we do. No, I don't think we do, but if not, I'm sure someone, like we don't, but like one of the great things about Raspberry Pi is that the community goes and builds things as well. So there might be a third party out there that I don't know of that's done it.
Yep, feel free to field that to the Element 14 community by clicking on the Raspberry Pi space as well. And we have 850,000 registered users who might be able to help you out, at least one at least. Yeah, we've got a couple of people asking the same question, so I may as well ask it while I've got you. Why did you decide not to add Wi-Fi or Bluetooth at the very beginning, this first iteration of the RP2040?
On Pico?
Yeah.
On Pico.
On Pico, yeah, sorry.
So RP2040 is, as a chip itself doesn't have any Wi-Fi capabilities, and Pico W doesn't add Wi-Fi into the chip. It adds a second chip. In fact, I'll just go back. So the big silver can you can see on the left underneath there is 43439, which is a Infineon radio part. So that's the radio part, and Pico, the black square in the middle, that is just RP2040, and that has no radio circuitry inside. Mainly that you can, like, in terms of product development, like producing a microcontroller board was our plan, was to have something that had RP2040 on it, and then adding Wi-Fi was not a non-trivial piece of work, and being able to kind of like pipe clean the whole process with Pico was brilliant. So we got all our manufacturing tests figured out. We got how we would package and sell it. So we try and make, because it's a very, very low cost product, try and make it easy and low cost to package. So it's actually packaged into tape and reel packaging. So there's a bunch of robots in Sony that test the board and then put it into tape and reel, and then we sell reels of Pico. And that really goes back to this idea that we think of it as a module that you could put into a product. So you could realistically load a reel of Picos up in your pick and place machine, and part of your reflow process is to pick and place a Pico into there. So getting all that right was why we did it without Wi-Fi. And then really the amount of work for the Wi-Fi has been considerably large. Lots of we're doing a very interesting way of interfacing RP2040 with the Wi-Fi chip. So we actually do everything over the SPI bus, rather than usually you have a bus for Wi-Fi and a bus for other things, and we've been able to get it all on there. So there's been custom firmware written, and there's been a big collaboration with us and the Wi-Fi vendor. So.
That's a fantastic answer. We absolutely love the PCB antenna as well, which is always really fantastic technology to see in there.
It is a fantastic thing, yeah. Go and talk to ProAnt if you ever want one. They will happily license you it. Incredibly good. Yeah.
We have a question from one of my team members actually, who has always got some great questions. What's been the most surprising application of the RP2040 or the Pico so far that you've seen? Which ones have kind of surprised you or blown you away?
I think what has really surprised me is how like some of the big orders that have come in for it, where someone's spoken to us, bought a Pico for a few weeks, their engineering team gone, wow, this is amazing, and then the kind of confidence that these companies have had in us, that they've shifted tens or hundreds of thousands of pieces of orders onto us straight away based on a quick evaluation, and the trust and the willingness that they're able to say was like, oh, it's a Raspberry Pi developed product, it will work, and they've gone and done that. We're seeing great stuff. Picos are popping up everywhere. Like the sort of Pico stuff is popping up mainly in hobbyist areas, and sort of RP2040 based things are popping up in the more industrial ones, which is sort of the way we thought it would go. But yeah, there's I think the usual thing of everyone's connected to something, connected a bit of everything to a Pico already. So it's great to see. Yeah.
Fantastic. We got a question from Gary here. Will the Raspberry Pi website publish tutorials on using TensorFlow Lite or other machine learning applications? I can only seem to find them on the Arduino website at the moment.
I think there might be a bit. I think it might be on there's nothing I'm aware of at the moment that's been planned, but that's not to say it won't happen. I think it's just a resource issue on our side more than anything. Is that everyone's working flat out on things, and just there hasn't been time to do it yet. But yes, I feel like that is a useful resource. Yeah.
I think now that you've said if people want to get in touch with ideas, with the questions box is filling up with ideas here. But my favorite one at the moment at the top, right at the very top, is any chance of a reset button with the version with the USB socket. So that'll be the Pico. Any chance of a version with a reset button? So there's a suggestion for a feature. Yeah, power cycle button. Yeah. Mm.
Well, we're not great on power buttons, are we? So I think everyone's wanted a power button for 10 years now, and we're yet to cave in. So probably not.
I didn't want to throw you under the bus on that one.
Power out, plug it back in again.
Love it. Okay, so we'll just go for two more. We still got loads coming in. We will post them underneath the recording as well. So maybe if we've got some extra time, we'll see what we can do to answer them. Let's have a quick look. So might we see something such as a Pico W, but with 802.15.4 wireless in the future for thread and IoT development?
Yeah, so there's other radio standards that we are actively thinking about. It's not clear which one's the right one to go for. We've always picked very sort of well-established communication standards, so like Bluetooth and Wi-Fi is the ones we've always had, and we've never done anything in the sort of the proprietary world. That's not to say never, but we've never been convinced enough, should we say? I think there's some thread-based boards that plug into Pico that would mean you could run thread-based applications with a sort of Pico plus a hat sort of thing. But yeah, it's an interesting one to think about. I can't say anyone's yet been convinced fully of one. So.
And there is a repeating question, which that might not be the right application for this, but how do you protect code on the Pico or the RP2040? That tends to be a common question that we've been getting in today.
Yeah, so we don't have anything like ARM Trust Zone at the moment, so we can't do signed code. If you were very particular about your code, you could use TPM and key your code in the flash so that you would be able to decrypt it with that TPM. Securing is such a sliding scale, and it means things to so many different people. So we are aware, that there's this requirement out there, and certainly I think we would address that in future things. Right now, there's some level of protection. You're probably, if this is the wide range of it, we're probably 2/3 of it all the way. You're never going to get fully protected because someone could always just sit there and solder wires onto your traces of your PCB or something. So that you get into the weeds of what secure is. Certainly there are ways to do it, but I just agree there isn't an ARM Trust Zone thing in RP2040.
Fantastic. Thank you very much for answering all the questions, honestly. It's been really good. Thank you to everybody that submitted a question today. As I said, we do have a big giveaway. We're giving away a giant Raspberry Pi 3. All you need to tell us is where you are going to show it off and where you're going to put it, because it's a fantastic model, and we want it kind of displayed prominently. It deserves to. There's a bunch of reading. There's Raspberry Pi for vertical farming and a bunch of stuff in the ebooks area. And there is more reading on the Raspberry Pi 2040 in the links on the right. We will be back on the 29th of September with James, and we will be inviting everybody that turned up to this. I'll be sending you out an email and adding it to the bottom of this event. Roger, thank you so much for joining us today. It's fantastic, as always, to have you, and the community really appreciates being able to bombard you with all their questions. So thank you for taking time with that.
It's absolute pleasure. I love talking about clever things that we've done. If I haven't answered your question today and you would like an answer from us, please email me at applications@raspberrypi.com. I can see some questions in the chat that I would love to talk about. So please feel to reach out and we will have a good discussion, because this is exactly what we need to be doing. So please get in touch.
Thank you. This video will be VOD almost immediately. So if you or your friends or colleagues have missed out on this, please send them the link and you can just watch it as we've shown it here. Thank you very much, Roger. I've been Phil from the Element 14 community, and that's us for today. We will see you back on the 29th of September.
Bye-bye, everyone.